Hello and welcome to another free code session. My name is Jason Bach and I'm going to continue doing some stuff with EditorConfigGenerator. I think I have this one statistics file thing pretty much done. That's led to a couple of other things that I want to look at. But the first thing I want to do to include in this is actually not a change related to this. I know purists would say I should put in another issue, do a branch at that, and I may do that, but I want to just check quick to see if a hunch that I have is actually correct. So what I'm actually going to do is, what we have here is this node is this, node is that, and I think, fine, we'll create a new project, and I'm just going to do the console app. 21 is fine, because we don't really care about this. But if I come back here and I say node kind, so kind here is a syntax kind. If I say syntax kind is equal to, kind, oh yeah, it's a method call. And then you could do class declaration and so on. You can also do raw kind, which then you do is equal to, and this is something that has always bugged me about oh, for God's sakes, syntax kind, yeah, class declaration, okay, is that you can't, raw kind is an int here, but you have to cast this to an int. I always think that that's, I know there's been reasons and why you do that. There's kind, there's is kind. Yeah. So I want to look at just, if I do it this way, if I do it against raw kind, if I use the kind method, if I use is kind, is there any difference in performance? Because I'm a curious fellow, okay? So what I'm going to do here is kind benchmarks. Kind bench. That sounds actually kind of, they're kind. They're not mean benchmarks. We're not going to be putting anybody down. We have a safe space here. So we're going to say memory diagnoser, which should be smart enough to go, yeah, pull that in because that's what we want. Okay. And I believe this will be .NET Core 3.1, which is fine. That's fine. Just close this, sure. Okay. And we're going to have benchmark. Well, actually, before we do this, we want to have a constructor here that if I could type public that we're going to have is it syntax factory? Parse compilation unit. There. Okay. And what that will give us back is a compilation unit syntax. So var code is going to be equal to, and then we're going to just put a whole bunch of things in here. So we're going to say at blah, blah, blah. So we're going to say class A, okay, which has int B as a getter, okay, foo C as a method, oh, no, void C, okay. We could have a field in there as well, but we can also just say interface D, okay, and then we're going to have in here void E, and then within this class, we're actually going to do class F, because why not? Okay. And what do we all got here? Struct, interface. You know what? Let's put a struct in a class because we want to. Delegate. We could put a delegate in there. Could have put a property in a field and an event. But that's not really what I'm totally looking for. You know, void G. Okay. So what I want to do here is say var unit is equal to parse compilation unit of code. Okay. Now actually what I want to say is this dot unit. So read-only field like that. There we go. Okay, so now I'm going to have a bunch of different ways to do this. So now I'm going to have a benchmark to say public int get declaration count via is. Okay, so whoops, we need a method here. And so I'm going to say var count is equal to 0. I'm going to return the count eventually. And then we're going to say for each var node in this.unit descendant nodes. I'm going to go through everything. Okay. If node is interface declaration syntax, or node is property declaration syntax, or whoops, or node is member declaration syntax, or node is struct declaration syntax. Okay. You know, let's put a field in here. So let's move this down here, and we'll say private double H. Okay. So we can say, or node is property declaration syntax. So if it's any one of these, which for all the things I've done, let's actually have this do something. Okay, so we're going to say you'll take in an int start. So we'll say for var I is equal to 0, I less than we'll just say iterations. I less than iterations, I plus plus, and we will say var result equal to 0. We'll say result equals plus equals of I, just to do something, and then we'll say return result. Okay, so we will say here count plus plus. And I could do this probably yeah, I could do that in the link statement, but I'm going to do this the same way in all of them because I wanted to, you know, I guess I could just say, I guess I could get all the nodes. Yeah, let's do that. Let's say that descendant nodes. And we will call this nodes. Okay, and that is, take that, and that is an, and then we'll say toList on it. So that is going to be a toList, a list of syntax nodes. A list of syntax nodes. Okay, so then what we're going to do in here is just do that. So, okay, why are you complaining up here? List system collector injects. Huh? Why don't you know what a node is? Because you don't know what a node is. There you go. Nah, good boy. Okay, so we're going to do via is, and then we're going to do via kind. So we're going to say node.kind is equal to syntax kind interface declaration, or we can kind of so we have to take the syntax off. No, we want to say method declaration here. Of course it's going to be a method. I think I screwed that up in another video where I meant to say method declaration and I put in member declaration. Should get all my decals right. Okay, so we do all that. Wait a minute, why do we have two property declarations here? That doesn't make any sense. We need a field declaration syntax there. Field declaration syntax, okay. Now we're going to say isKind. So what does that look like? No.isKind. Passing in what you want to say. Is it that? Compared to isKind. Compare it to that. Compared to isKind. Compare it to that. Again, this is just pure curiosity. Which one is going to be quote-unquote better? And you can even complain about the test here because it's like, is it really that fair? You know, isKind. And then we're going to take this. We're going to, whoops, nope. I'm going to copy and paste all the things. There you go. Okay. Now I'm going to say rawKind. Oh, yeah, no, that's fine. rawKind. So we're going to, and then we have to say here, right? Yep. So we're going to be H. So take that, and what we want to say is rawKind equal to int, and we're going to say current block. Boom. There we go. Okay. What? How did an argument null exception happen because of that? Okay. Yeah, this is going to be simple to parse. Holy crap. Yeah, system arguments. The collections refer to different snapshots. Well, Microsoft, if anybody's watching this right now, there you go. It was referring to different snapshots, and the normalized snapshot overlaps with snapshot, find, scope, highlight, tagger, move next. That you can just like, I'll just say point to this video, and yeah. You know, you can just stop wherever you were, Watson. There you go. So I'm guessing that's it. I have no idea. Okay. Anyway, let's go back to program here. And what we're going to do first is say var benchmarks is equal to new kind benchmarks. And we're going to say console.out.writeLine, because I want to make sure that all my benchmarks, that all these are the same. Okay, then we need to be in release mode. Let's run that. See what we get. They're all 7. Okay. And you know, if I really wanted to, I could just take this and just repeat it again. So I'll have AA, HH, CC, FF, GG, good game, BB, DD, and E, and now we should have 14. And we do. Okay, so we'll see how this runs first. Benchmark runner.run kind benchmarks. Okay, did I miss anything? Did I miss anything? benchmark. Okay, so I'm going to let this run, and then I will come back and when I see the result. But I want you to guess, which one do you think is going to be the best? Is it going to matter? I might have to increase a bunch of stuff here to make this actually give a meaningful result. But we're going to run this the first time, and we're going to see what happens. All right, so think about what you think, and here we go. And I will come back once this is done doing all the calculation. All right, we are back, and there are the results. There's no difference in memory allocation, which kind of makes sense. The type check like an is there, I bet wouldn't do any memory allocation. But you definitely don't want to use is kind. That's the worst. The raw kind actually seems to be the best. So if you're just looking to find the type kind, or the node kind, raw kind, even with that cast there, seems to be the fastest way. Now, of course, the person that I am, I'm going to actually double the size of the tree again and put in just more stuff, and I'll run this. So let's go back up here, and take all that, and we're going to go it's a Saturday, whatever that means. BBB. I'll do one more, and I will capture those results. No, wait a minute, I need to do basically need to double these just to get them all unique. Again, probably not the smartest names in the world, but this again is just a quick test. So we're going to grab these and put them into there. Okay. Stop that. Save that. Come here. Comment that out. Nope. And they're all good. All right, so again, I will run this. And once the results are done, we'll take a look at them again. And we are back. And let's just grab the numbers here and see if they're, now I didn't think this through. What I should have done is put the baseline on one of them to see what the difference is. But yeah, they look about the same to me. They look about the same. And again, raw kind is the same. I'm going to put on Twitter, I'm going to put in there, pop quiz Roslyn hotshots. What's faster? When you're looking for the type of a node, do you use is? Do you use kind? Do you use is kind? Or do you use raw kind? Which one's best? And see what people guess. So I'll put that out there as like a poll and get like 2 people to respond. But this is good because what this says to me, and this will again show the power of and I should, the purists out there are probably going, oh no, I can't do that in this case because I am capturing, in this case I can't do that because I am actually capturing the thing, but down here I don't. So somebody say, you shouldn't put this in this branch because this is for this feature and you're doing the wrong thing. And I'm like, yes, I am. Shut up. I am so... I am an encourager. I really am. I totally am an encourager. Okay, so we're going to have to... Did I actually... I had to have. Yeah, I did. Okay, I must have did the thing with the stuff. So we're going to do... Oh, and then we need to say... No. I'm doing this wrong. Int. Syntax kind. That. There we go. Okay. So we need to copy all that, come over here, and do that to that, do that to that. Our node is... Okay. And then once more with feeling down here. Nope. Too far. The node too far. Ah! I cracked myself up. So not a bridge too far. It's never mind. All right. And again, we capture that one down there. And there may be more cases that I do this in code somewhere. But if I run all these, what should happen now is nothing should break. Should be in the operative word. Let's get rid of this here. So I captured that. No failures. Okay, good. So I'm going to commit this, and then I'm going to add one more testy test. Not test, but okay. So I'm going to say number 3, finished creating stats. And I got to get better about putting the referencing the feature number there. I never published the branch. Okay, fine. We're going to publish it now so that we can delete it in about 2 minutes. Okay. Go to master, branch, merge in the current branch, this one, merge, push. I should have put the summary. I'm such a bad person. Okay, and then we come back to this one, and we delete it. Yes. And Bob's your uncle. Or Alice is your aunt. I don't know. Whatever you want to say. Okay. So if I come back here, this should all still be that, which is good. That is good. Come over here. And now we should at least save one thing here. Yes, we do. We can close that issue. Okay. Which is great. That is awesome. I do want to look at the milestones. Open. So we have tracing, consistency, and conventions. The one thing I want to add is add valid. That's right. That's right. That's right. Add validation to data constructors. Make sure that all data objects on their constructors have valid totals for their parameters. If not, throw a... Oh, I can't... I was driving my older son to self-defense today, and I was thinking of this, and I was like, what's the name I want to have this? Invalid... I think I said invalid. I should have just pulled the car over and like wrote it down somewhere. Valid data state exception. Come up with a better name. Okay. And we will assign this to me. We will give this enhancement. We'll give it enhancement. That sounded weird. There we go. Okay. So this is just, again, make sure that I don't ever put any of these data objects into an invalid state. So if we come back over here, we go to issues, go to milestones, and we look at which ones are here. Validation, tracing, create conventions, consistency value. Which one do I want to tackle first? Which one? Oh, Jason. Which one do you want to do? This almost... Okay, yeah. So I'm going to stop the video. I'm going to put the post out there in Twitter just so I don't forget. And say... And put that out there. And then I'm going to record another episode. We're going to dive into either the consistency value and or the validation. Either one. So, stop for right now. Thank you all for watching. Leave comments and questions below. See you in the next episode.